Hello viewers, welcome to Math Lila channel. Today we are going to apply first principle in order to find the derivative of a given function. So if y is equal to function of x, then dy dx is equal to limiting value as delta x tend to 0, function of x plus delta x minus function of x all over delta x. First principle can also be expressed as y plus delta y equals to function of x plus delta x. All of these two are almost the same, all they are equal, but it's just different way of expressing them and different way to apply them. Now let us solve this. Find the derivative of the following from first principle. A is x, we are going to find the derivative of x. B is derivative of x squared, and c 2x plus 1, d x squared minus 3x, e 1 over x, and all these are a function of x. So now in order to find it, starting with equation A, we say let y equals to x, because x is our function, so it is assuming the function. And then in order to apply first principle to find the derivative, we are going to find this, and then we find this, and then we evaluate the whole expression from the numerator, and then we simplify the whole numerator and denominator. So follow us and you see how we are going to apply the first principle. In order to simplify all this expression, we start with the first expression, and the first expression is function of x plus delta x, and this function of x plus delta x is the same thing as x plus delta x. That is the function. This expression is standing as x. Wherever you see x, you are going to, when you come to evaluate this expression, you will just assume it to be this expression, meaning that in this function we have only x. Therefore x in first principle, from the first part of the first principle, it is represented by x plus delta x. Therefore this is our x. And also we are going to find what is function of x. Function of x is already given. Function of x is equals to x. Then next we are going to find function of x plus delta x minus function of x. Then function of x plus delta x minus function of x is equals to, what is our function of x plus delta x? Is this, is our x plus delta x. Then minus this, minus function of x, and our function of x is this. Therefore we have x. So as you can see, x goes with x. Therefore what left is only delta x. Then we evaluate function of x plus delta x minus function of x, that is the numerator. Then we combine the two in order to simplify the both numerator and denominator. Therefore function of x plus delta x minus function of x all over delta x is equals to this top numerator, we simplify it as delta x, and then also we have numerator of delta x. So as you can see, this cancel this, which is equal to 1. Then we apply our limiting value as delta x tends to 0 in this case to find our derivative, that is dy dx. Our dy over dx is equals to limiting value as delta x tends to 0, function of x plus delta x minus function of x all over delta x, and this function is evaluated as 1, therefore is the same thing as 1. Where do we apply this limit? In a situation where we have delta x somewhere in the expression, then we substitute it with 0. But now it's already we already eliminated from here, as we divide numerator and numerator by the same delta x. Therefore, our dy dx is equal to 1 if y equals 2. In order to apply first principle in question B, we let y equals to x squared, and we know our first principle is given by dy dx is equal to limiting value as delta x tends to 0 function of x plus delta x minus function of x. And we know we are going to always evaluate this first expression and then this, then the whole thing, then we apply our limiting value as delta x tends to 0, then we find our dy dx. Now, let us evaluate function of x plus delta x. Function of x plus delta x, we said, is always standing as our x. Therefore, x plus delta x is always standing as our x. Therefore, we are going to write x plus delta x. But our x here is squared. Therefore, we are going to square them. Now, how are we going to expand x plus delta x squared? We can either put two identical brackets and open it and expand it, or we can expand it directly. We know that if we have a plus b squared, this is the same thing as a squared plus 2ab plus b squared. Then we can apply this in order to expand it. You know, our a is x and our b is this. Therefore, we can have what? X squared plus 2x delta x plus delta x squared. That is evaluation of function of x plus delta x, and it gives us x squared plus 2x delta x plus delta x squared. And also we are going to evaluate this, that is function of x. Function of x is our function given, therefore function of x is x squared. Then we evaluate function of x plus delta x minus function of x. Therefore, we evaluate function of x plus delta x minus function of x. Function of x plus delta x is this one. Then we write it x squared plus 2x delta x plus delta x squared minus this minus function of x, and our function of x is x squared. You know, this x squared cancel this x squared, therefore this is equals to 2x delta x plus delta x squared. That is what? That is function of x plus delta x minus function of x. Then we evaluate it with the numerator. Then we have function of x plus delta x minus function of x all over delta x is equals to 2x delta x plus delta x square all over delta x. You know, we have delta x here, we can factor out 1. We have 2x plus delta x all over delta x. This delta x cancel this is equal to 2x plus delta x. Then we evaluate this, as you can see from this. Then we apply our limiting value delta x tends to 0 to find dy dx. Therefore, dy dx is equals to limiting value delta x tends to 0 function of x plus delta x all over plus delta x minus function of x all over delta x is equal to 2x plus 0. Whenever we apply this limit as delta x tends to 0, after we simplify it, wherever we see delta x, we substitute it as 0. Therefore, we have our dy dx is equals to 2x if what? If y equals to x squared. Also, to evaluate question C, which is 2x plus 1. Then we let y equals to 2x plus 1. Then also from our first principle, we know we have dy dx is equals to limiting value as delta x tend to 0, function of x plus delta x minus function of x all over delta x. And as we usually apply, we have to evaluate the first function, that is function of x plus delta x is equals to, we said that wherever we see x in the expression, we substitute it with x plus delta x. Therefore, we have 2 open bracket x plus delta x plus 1. That is our function of this. And function of x is the function given, that is 2x plus 1. Then we are going to evaluate the top expression, function of x plus delta x minus function of x. Function of x plus delta x minus function of x is equals to, function of x plus delta x is this one. Then we have 2 open bracket x plus delta x plus 1 minus 2x, that is function of x, this function of x, and this minus is this minus function of x is 2x plus 1. 2x plus 1. Then we expand the bracket. We have 2x, 2 times x, 2x, 2 times delta x is 2 delta x plus 1. Minus times 2x minus 2x minus times plus 1 minus 1. As we can see, minus 1 cancel 1 plus 1, minus 2x cancel 2x. This can be simplified as 2 delta x. Then we also simplify our the whole expression, function of x plus delta x minus function of x all over delta x. Therefore, we have function of x plus delta x minus function of x all over delta x is equals to, we know that function of x plus delta x minus function of x, this one, we obtain it as 2 delta x all over delta x. This delta x comes, then we find our dy dx. Our dy dx. Our dy dx is equal to limiting value as delta x tend to 0, function of x plus delta x minus function of x all over delta x is equals to, sorry, there is no 0 here, it's just 2, this cancel this 2, is equal to 2. Therefore, dy dx is equals to, as you can see, there is no any delta x whereby we can substitute it with 0, then we just leave our answer with the constant. Therefore, our dy dx is the same thing as 2 if y equals to 2x plus 1. Question D. In order to apply first principle, which is given as dy dx is equals to function of x plus delta x minus function of x all over delta x. In order to apply it, we firstly evaluate this. We have function of x plus delta x. As we said, wherever we see x in our expression, we substitute it with this one while evaluating function of x plus delta x. Therefore, here is x. We substitute it with x plus delta x, and it is square, we put square, minus 3. Here is x. We substitute it with x plus delta x. When we simplify this, we are going to have, as we expand the square, we are going to have x squared plus 2x delta x plus delta x square. Then we expand this bracket also, minus 3 times x minus 3x minus 3 times plus delta x minus 3 delta x. This is the evaluation of function of x plus delta x. Then our function of x is equal to the function given, x squared minus 3x. Then we evaluate function of x minus delta x plus delta x minus function of x. When we evaluate this, we just find substitute this as this, and we substitute this as this. We have equals to x squared plus 2x delta x plus delta x square minus 3x minus 3 delta x. Then that is our x plus delta x function. Then minus the function of x, that is minus open bracket x squared minus 3x. Then we simplify this. We can see when we open bracket, this is minus x squared minus 3x. Plus 3x, since it is minus. Therefore, as you can see, this x squared goes with this, and this plus 3x goes with this. What left here is 2x delta x plus delta x squared minus 3 delta x. We evaluate a function of x plus delta x minus function of x. Then we evaluate this. But before we evaluate this, let us factor out delta x, because we have it in the three terms that we have. The first time we have delta x, second time we have delta x we have here. Then we can factor out 1. We have 2x. When we factor out delta x, remain 2x. Here, when we factor 1, delta x remain delta x. Here, when we factor delta x, remain 3 in bracket delta x. Therefore, now let us evaluate the here is limiting value as delta x tend to 0. Therefore, let us evaluate this. We have function of x plus delta x minus function of x all over delta x is equals to, this is the top numerator is simplified as this. We have 2x plus delta x minus 3 delta x all over delta x, delta x, delta x. This delta x cancel this. We have a function of x plus delta x minus function of x over delta x is equals to 2x plus delta x minus 3. Therefore, we apply our limiting value as delta x tends to 0 in order to find our dy dx. Therefore, dy dx is equals to limiting value as delta x tends to 0, function of x plus delta x minus function of x all over delta x is equals to, we said that whenever we apply the limit, wherever we see delta x in the expression, we substitute it with 0. We have 2x plus 0 minus 3. This is equal to 2x minus 3. Therefore, dy dx is equals to 2x minus 3 if y equals to x squared minus 3x.
Thank you for watching. Please subscribe to my channel and turn on your notifications so that you will be notified whenever we upload our next video.